Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, welcome. I'm Teacher John. I'll be taking you through mathematics, Senior 2, Unit 2, deal with polynomials. Polynomials. Dear students, I know you have been learning about polynomials, even if from Senior 1 even to Senior 2. But today, we are going to pass through different operations on polynomials and to see more about polynomials, especially the equality of two polynomials. But before that, let us start by having this activity. Please get your exercise book and your pen, even calculators if necessary, to work out this exercise. Given that f of x is equal to x squared plus 7x plus 12, and g of x equals x plus 4, find A, the sum of f of x and g of x. B, the difference between f of x and g of x. C, the ratio of f of x by g of x. And D, f of negative 3 times g of negative 4. You have 1 minute. Hurry up. Hurry up, please. Feel free to give any comment. If you have any question, ask. I'm here for that. Feel free. Feel free. And mathematics is very, very simple. As we deal with these polynomials, very, very interesting, very important to our life, because it will help you in construction, for instance, the bridge, for instance. Different designers, they use polynomials in their activities. Hurry up. Are you done? I give you just a few seconds. Are you done? Nice. Thank you very much. Now, let us make the correction together of our exercise. Please, eyes on me. Eyes on me. Thank you very much. Now, we have our two polynomials, and now we need the sum. Answers. F of x plus g of x is equal to f of x is x squared plus 7x plus 12 plus g of x is x plus 4. And we'll be having, remove this bracket, we have x squared plus 7x plus 12 plus x plus 4. When you add polynomials, we add like terms and you combine them to reduce them. We have x squared is alone. We have the term in x, we have a 7x and the x. These are known as like terms. We have to reduce them. 7 plus 1 is 8x. And you have constant term or term independent of x. 12 plus 4 is 16. Very simple. Isn't it? Nice. Now, B, f of x minus g of x, the difference, we will be having x squared plus 7x plus 12 minus x plus 4. I'll be having x squared plus 7x plus 12, removing this bracket, then minus x minus 4. As we did before, here we have x power 2. Here we have like terms 7x and minus x. Reducing them, we'll be having 6x. Then 12 minus 4 is equal to 8. Very simple. Is it clear? Thank you. Now we need the quotient f of x divided by g of x. So by long division, I have x squared plus 7x plus 12 divided by x plus 4. You know, I take x squared divided by x, I'd be having x, then x times x plus 4, it will be x squared plus 4x, then subtract this quantity to the dividend, x squared minus x squared is 0, 7x minus 3, 4x will be 3x, then I bring down 12, then I take 3x divided by x, which is equal to 3, means I have a 3 there. 3 times x is a 3x. 3 times 4 is 12. Then subtract this quantity. I'll be having 3x minus 3x is 0. 12 minus 12 is equal to 0. This is the remainder. That is the quotient. Of course, this is the divisor, and that is the dividend. So, f of x divided by g of x is equal to x plus 3. It means f of x is equal to x plus 3 times x plus 4. Now, the last f of minus 3 times f of minus 4 is equal to, we enter our polynomial, x will be replaced by minus 3, and here x will be replaced by minus 4. I'll be having minus 3 squared plus 7 times minus 3 plus 12 times minus 4 plus 4. Already, when I have minus 4 plus 4, this is equal to 0. Any quantity times 0 is equal to 0. So the result will be 0. We are done. Compare the answers we have here on chalkboard with those you have got. Are they the same? Are they similar? Yes? Thank you very much. That's very, very good. Now, we are going to continue with these polynomials, but now, equality of two polynomials. That is our purpose today. Equality of two polynomials. Equality of two polynomials. Follow on chalkboard. Equality of two polynomials. Let us have f of x to be an x power n plus an minus 1 plus x power n minus 1. A3 x cubed plus A2 x squared plus A1 x plus A naught. And g of x equals b n x power n plus b n minus 1 x power n minus 1 plus b3 x cubed plus b2 x squared b1 x plus b naught, where an minus 1 up to a naught, bn minus 1 up to b naught. All these are coefficient. It means these are real numbers, okay? And the n is a non-negative integer. So these two polynomials, f of x and g of x, are of the same degree. N, it means an is the leading coefficient for the first polynomial, and bn is the leading coefficient for the second, g of x, while b naught is the term independent of x in the second polynomial, and a naught is the term independent of x in the first polynomials. So these two polynomials, f of x is equal to g of x, if and only if, first of all, both polynomials are of the same degree. They are of the same degree. 2, like terms are equal. The coefficient of like terms are equal. And the 3, they have the same number of terms. They have the same number of terms. This is very, very crucial for equality of two polynomials. They must be of the same degree. For this situation, the degree is n and degree is n. The coefficient of like terms must be equal, and they may have the same number of terms. Wherever the term is not there, it can be replaced by 0, isn't it? Thank you very much. For instance, if these two polynomials are equal, an must equal to bn, because these are like terms. An minus 1 and bn minus 1 are like terms, so this must be equal. A3 and b3 must be equal. A2 and b2 must be equal because these are the coefficient of like terms. And a1 must equal to b1. Even a naught and b naught must be equal because both are term independent of x. Are we together? Are we together? Is it clear? Thank you very much. Now, I give you just 1 minute to copy down this in your textbook for reference. Then we'll be having examples of equality of two polynomials. Hurry up. Hurry up, please. Equality of two polynomials is very, very important. Very important. Yes, I think we are done. Please, here we have an example. Follow on chalkboard, please. Yes, thank you very much. We have two polynomials, f of x, which is equal to 3x squared plus 1 minus a, bracket x, this is x, plus a 3, and g of x is equal to bx squared plus 9x plus a 3. And you have to find the value of a and b if these two polynomials are equal. If f of x equals g of x. Please follow on the chalkboard. I told you that two polynomials are equal if they are of the same degree. That's one. Our polynomials are of the same degree. Their degree is 2 and degree is 2, right? Thank you. Now, the coefficient of like terms must be the same. Here the coefficient of x squared, it is 3, and the coefficient for x squared for g of x is b. It means b equals 3. They are like term. Then the coefficient for x must be equal to the coefficient for x there, right? Nice. So we have 1 minus a, which is equal to 9. And solving this, we'll be having we have minus a, which is equal to 9 minus 1. So we move a 1 to the right-hand side. Then minus a is equal to 8. Multiplying by minus 1 both sides, a is equal to minus 8. It means f of x equals g of x if a equals minus 8 and b equals 3. Is this difficult? Not at all. It is very simple. Would you like to have another example? Yes, thank you. Let me give you another example for that. Another example. It is very simple, very, very simple. Very simple. Another example. Let us take f of x, which is equal to 2x power 3 minus b x squared plus 3x plus c, and g of x equals, they take ax cubed plus 6x squared plus 3x, then plus 5. Then find the values of a, b, and c if these polynomials are equal. The matter is to know if they are of the same degree and the coefficient of like terms are equal, right? Follow? The coefficient in x power 3, we have a 2 and the a. It means a equals 2. The coefficient of like terms in x power 2, we have minus b and 6. It means minus b equals 6. Then, for term independent, you have a c and 5. It means c equals 5. This means that a equals 2, b will be equal to minus 6, and c equals 5. Is this difficult? It's a simple game. Thank you very much. Now, I give you just 1 minute to write this in your notebook, and you have an activity after that. I'm going to put the activity on chalkboard while you are writing these examples in your textbook. Hurry up, please. Hurry up. You have 1 minute to do that work. 1 minute only. Are you done? Few seconds. Hurry up. Few seconds. Few seconds. Of course, in your exercise books, it's already known. You have a few seconds. And you make a correction on chalkboard together. Are you ready? Are you ready? Nice. Okay. Thank you. Let us start by number 1. We have our polynomial is f of x equals ax power 3 plus a x squared plus bx, then plus 12. And then f of minus 2 equals f of 3. F of minus 2 equals f of 3 equals 0. Then we have to find the value of a and b. What you know, f of 2 equals 0. It means when we replace x by 2, we'll be having 0. F of minus 2 equals 0. This is a times minus 2 times power 3 plus a minus 2 squared plus b minus 2 plus 12 equals 0. This is minus 8a plus 4a minus 2b plus 12 equals 0. And a for 3 is equal to 0. A for 3 is equal to 0. I'll be having a 3 power 3, a 3 squared, b times a 3 plus 12 equals 0. And this is 27. A plus 9. A plus 3b plus 12 equals 0. And we have solving these two equations, we'll be having this is minus 4a minus 2b plus 12 equals 0. This is 36a plus 3b plus 12 equals 0. The first equation can be multiplied by 9 and 1 there. We'll be having minus 36a minus 18b plus 12 times then 1 is 8 equals 0. And have 36a plus 3b plus 12 equals 0. The sum, these are vanishing. We have a minus 15b plus 120 equals 0. It means 15b equals 120. Then b, if we divide it by 15, then it is equal to 8. Then b equals 8. We can find the value of a from here. Minus 4a minus 2 times 8 plus 12 equals 0. This is minus 4a minus 16 plus 12 is equal to 0. Minus 4a minus 4 equals 0. 4a is equal to minus 4. Then a is equal to minus 1. Very simple. We have the value of a, we have the value of b. So it is the same for those ones. As you know, you can recognize easily the real part, the coefficient of like terms. For this one, what I'm going to do, you have to expand this, then you will take the coefficient of x squared, which is equal to 3, and the coefficient of x will be equal to 20, and the term independent will be equal to 24. And this one is the same. It's a matter of times. This is, if you solve this like, this will be a, this is x squared minus 1, this is ax squared minus 2. Ax minus a plus bx minus b plus c. It means a is equal to 2 and minus 2a plus b equals minus 1. And of course, c equals 1. When you have the value of a and you have the value of b, it means that you have minus 4 plus b equals 1. So b is equal to minus 1 plus 4, it is 3. And you are done. This is reserved for your auto-evaluation. Are you together? Here you have a homework. Observe this homework. It is very simple. In each case, you find the value of a and b. Thank you very much. Thank you for today. Stay doing mathematics. I wish you all the best.